So 3D trig. The angle of elevation of a tower CD of height h meters from a point A due east of it is 28 degrees, and at a point B due south of it, the angle of elevation is 36 degrees. A and B are 400 meters apart and on the same level as base D of the tower. Whole lot of bunch of words, which sounds confusing. But what it's saying is that there's a tower, CD, and the base is D. There it is, right? It's got a height h. There it is. From a point, and the angle of elevation from a point A, which is due east of it, there's A. The angle of elevation is 28 degrees. Okay, I think most of us understand that bit. It's how to actually draw this 3D trig that a lot of students, I guess, are very poor at. The trick is, this is an x-axis, this is a y-axis, this would be a z-axis. Z-axis is what you would need for 3D trig, or 3D, any 3D shape. So it says there's a point B which is due south of it, and to draw point B, we actually draw it like this. There's point B. And the angle of elevation from point B to the top of the tower is 36 degrees. Maybe you guys are already seeing my 3D trig coming into place. A and B are 400 meters apart. Sorry?
I think I did this last year. The 3D.
Okay. Yeah, perfect. Yeah, you would have done it with probably a bit of at school, but you would have also done it in our 3D trig booklet as well. A, B is 400 meters apart, and that's about it. Okay. Anybody confused how I got that? You can pretty much memorize this shape. I do recommend memorizing this shape. It will be more likely that it will be this particular shape that you'll get in an exam. Okay, and what do we know? We know that this is a tower and this is the ground, right? So that's a right angle there. We know again that this was east and this is south. So again, this is a right angle there. And of course, again, to the ground and the tower, that's a right angle there. You guys understand that? So this is vertically out of the ground. So this will obviously be a right angle there and there. But this one's right angle because it said east and south. So east and south are 90 degrees to each other. Any questions? Now, the trick to 3D trig is not to actually find h. The problem is you're going to get a question that's going to say, you know, find the height of the tower. Now, if you look at, let me just show you an example. If you look at this question, right, it says find the height of the pole. And the way you would find the height of the pole is you'll do, you know, let's just say SOHCAHTOA, do the opposite of adjacent, and you'll eventually find h. Or if you said find d, you will do some sort of trig to actually find d. If it asks you to go and find d, again, you'll do something to find d. If it asks you to find this d, again, you'll do something to eventually find this side d. The trick with trig here is that if it asks you to find height, you're not going to find this side here. And that is what's weird about it. You don't find this height from here, this side. What you're meant to use is actually this triangle. This triangle will allow you to find this height. Use another triangle to find h. I mean, that's the biggest and the most important bit I can tell you, and why a lot of 3-unit students struggle with this, and then now why a lot of 2-unit students would really struggle with this. Because usually when we ask you to go and find h, naturally you're just like, oh yeah, sweet, let's start finding the side. Oh yeah, let me go do that. Oh, find the angle here. You'll start doing all this stuff to find this angle. But the idea of 3D trig, if I ever ask you to find the height of the tower, it's actually not to find the height of the tower using that triangle. It's using a different triangle. Please keep that in mind, and then the rest of what we're about to do should be fairly straightforward if you know that. Sometimes you might not be given A, so you have to know to use this triangle. So pretty much assume there was no A and B. You've got to assume that it was just find the height, and you have to know yourself to do A and then to do B. Okay? All right. In this case, obviously, I've broken it down. I've said show that AD is equal to H on tan 28. So find AD here, which equals to H on tan 28. All right. The way we're going to do that is using this particular triangle. I know that that's opposite over adjacent. So tan 28 equals opposite over adjacent, and then of course just cross multiply, or just multiply and bring this back down. So AD equals H on exactly what was needed. Any questions there? So now you just found this particular side as an expression of H. BD says find a similar expression for BD. So do it again. Tan 36 equals opposite over adjacent. So H on tan 30 BD. And then again, BD equals H on tan 36. You might see your teachers, write sometimes 1 on tan is cot. You ever see that? Try to ignore that, because you can't use cot in your calculator, so why are you writing cot? You might as well leave it as H over tan. So don't try to get confused and start using cots everywhere. Unless you really wanted to, that's a decision you got to make. All right. Seriously, any questions about part A? First find AD, then we found BD. Okay. Then B says, hence find the height of the tower. The way you will find the height of the tower is by actually using this yellow triangle. What you're going to use is Pythagoras' theorem. So you know that AD squared plus BD squared is equal to 400 squared. So again, AD squared plus BD squared is equal to 400 squared, which just means H squared on tan 28 squared plus BD squared is equal to 400 squared. Factorize your H squared out. You're solving for H, so factorize your H squared out. You're left with this. Plug this into your calculator and then just go 400 squared divided by this answer. Just to make it look a little bit better, because who's bothered rewriting all of that out? This is A. So 400 squared divided by all of this, and then obviously you just square root it. And we're going to try to do that in our calculator. But see how I found H? I found the height by using a different triangle. Now it's either going to be Pythagoras if it's a right angle, or it will be cosine rule if it's non-right angled, which will be the next question we'll do. Just so you guys can keep that in mind. Right angled, Pythagoras, otherwise cosine rule, and that's pretty much the idea. So AD squared plus BD squared equals 400, AD squared is that, BD squared is that. And the way you put these into your calculator, 10 squared 28, your calculator can't do it like that, but we write it like that. You have to close your brackets, and when you put squared after you've closed it, your calculator will do that. All right, so make sure, get your calculators out. I'm going to start doing it as well. And try to first get an answer for this, and then do 400 squared divided by that answer, square root it, and hopefully we can get the answers out. So let's see, 1 on 10, 28 squared, plus 1 on 10, 36 squared. For A, just so if you want to check, I got about 5.43155 and so on. And now I'm about to do 400 squared divided by that answer, and then square root that. The final answer you should get is 171.63. Now I can't move on until everybody confirms they can do that. So I'll wait, get your calculators out, and talk to me.
Yeah, got that.
Yeah, got it.
Oh wow, good, good.
Yeah, got it, sir.
Beautiful.
Yep.
Yeah, done. Okay. Anybody not get it, I guess? Anybody not understand how I factorize this h squared out? Any particular line? You know, you're trying to solve for h, so I would, you know, naturally you'd think you would like to factorize it out. Okay. All right, if there's no questions, then let's try and move on to another one.
Sir, by any chance, could you just do like another example, just for like slightly, like a different shape or something?
The shape is very.
Is it always a triangle? Like,
Oh yeah, yeah. Well, is it always a triangle? Yeah, of course.
all right, never mind then.
Yeah, it will always be a triangle, but it won't always be Pythagoras. And it won't always be. I don't know what else. It will always be a triangle. It won't always be Pythagoras. And sometimes you're going to be given bearings. So you've got elevation, but we need bearings as well, which I think is the next one anyways. So we'll do this one. So have a read of that. Draw up your diagrams. And then I will get started as well. Okay, what's the only thing that's actually different in this question?
It says due east 40.
Oh, no. You're probably reading that wrong. So the way you would have to read that bit is the angle of elevation is 40 degrees. So that's how we're reading this. It's just telling you of what. So that, unfortunately, that's a bit weird as well. But no, so it goes like this. The angle of elevation is 40 degrees of the tower, which has height h, from A. The angle of elevation is 40 degrees. And A is due east of the tower. So pretty much this again. D is on the base. There's your A, which is due east. The elevation is 40 degrees. Cool?
Mm-hmm.
And then what angle do you have here? for something that is on the ground and then the tower?
90 degrees.
That's 90 degrees, right? And then you're going to draw this one here. And then you got that there. It says the bearing of the tower is 42 degrees, which we will get to. Don't let bearings confuse you, I'll get to that. But the angle of elevation is 35 degrees. There it is. Imagine I'm standing there, I'm looking at the top of the tower, and that elevation is 35 degrees from the ground. What would this angle be in here?
90.
Also 90 degrees, right? That can't change. That's the tower, that's the ground. And then A and B are 200 meters apart. Ugh. There it is. The only thing is, B is not south of A, like the other one was. It's saying B, the bearing of the tower, sorry, from B, the bearing of the tower is 42 degrees. Okay. And I'll show you what that means. From B, the bearing of the tower is 42 degrees. So you got to imagine me on the ground, right here. And there's the tower. Bearings work from north, right? So the tower from B, that bit there, is 42 degrees. Do you get that? From B, the tower is 42 degrees. That means if I drew the same thing here, can you guys see alternate angles? That's the way I do my bearings. Alternate angles. Bang, there it is. 42 degrees in there. And obviously, what angle is that? That's 90 degrees. And that's what your bearings mean. So from B, let's read it again. From a point B, the bearing of the tower is 42 degrees. So from B, from where I'm standing, the bearing on the ground is 42 degrees. From north, there it is. This is elevation, it's lifting up. Any questions? Did I make that super easy? Because that is super hard. You guys get that?
Looks a
Yeah,
bit
that makes
weird.
sense.
Yeah, that's great. If you guys can really know what I just did there and replicate it each time, the way I've just done that bearing, I don't see you getting anything wrong. Let's finish this off.
So it
Show
looks
that
so
B.
simple though. Is it meant to?
What do you mean by it looks so simple? You know how
Like-
complicated this is, but I've made it simple.
Oh, okay.
Yeah, you're right. I made it look super simple because I'm just telling you guys, hey, just do it like this and do the bearings like this. But I mean, did you even think about drawing your bearing like that at 42 degrees?
No.
No. Would you have seen that would be north, and 42 degrees? Whereas a lot of students think, okay, what is happening here? Like, what is this line? Is that north or is this north? Or it's just a lot of everything going everywhere. But I'm trying to cut off all that. Let's call it BS, and just go, hey, look, this is where I'm at. Imagine I was facing north, and then I've got to turn 42 degrees. So turn my body 42 degrees. Now I'm facing the tower. Then imagine I'm just facing the tower, but if I want to look at the top of the tower, I've actually got to tilt my head up, and that would be the elevation.
Yeah,
So
makes
I've
sense.
simplified it, but realistically, this is meant to be very complicated.
Well, thank you, sir.
Show that BDA. BDA. I mean, look, you're done. If you do it this way, it's done. Show it's 132. Well, you'll just go from diagram. 90 plus 42 equals 132. I mean, Josh, you've done trig, you said, right? So did you do 3D trig?
Well, I remember doing 3D trig. Must have
You
been like
don't?
a small thing at the end of it. Yeah, it was just normal trig.
Yeah. Well, see, like, and was it? What? Did you find it easy? Did you find it like the way I'm making it sound? I don't know.
Oh no, the way Sir explained it was annoying.
Yeah. See what I mean? Like, it's meant to be, I guess, harder if you don't understand what's happening. But I'm trying to cut off all that because I really get what's going on and just go, look, that's what you guys need to do. If you guys can do that, you're sweet. So yeah, from a diagram, 90 plus 42 is 132. 90 plus 42, that's therefore angle BDA equals 132. BDA is 132. Okay, and we know pretty much what's going to happen. It's going to say show this side and this side is something in terms of h, and then eventually you've got to use that for this triangle to find this height h. Okay, this time it does change it up a little bit. It says show that BD is equal to h tan 55. What? We've got 35. Anyone have any idea of how to get this 55 that they want?
Angles in a triangle.
Yeah, right. Look at that's the only way you can make it any harder. We're just trying to trick students to put it up there. All right, there it is. That's 55 degrees, and then again, opposite over adjacent. So tan 55 equals opposite over adjacent. You want to find BD, just multiply the h. It says find a similar expression for AD. We already know that that's coming up. That's 90, that's 40. So that must be 50. Tan 50 is equal to opposite over adjacent. And then AD equals H tan 50. Okay. And then obviously, hence find the height of the tower. C. Okay. To find the height, again, you're going to use this triangle. All right, what are we going to do? Anyone have any ideas? It's not Pythagoras. That's 132 degrees now, so I can't use Pythagoras.
The cosine rule?
And do you know what the cosine rule is? C
Uh,
squared equals?
A squared plus B squared minus 2AB cos C.
Good work. All right, here we go. A and B, A squared and B squared are AD and BD. And then cos C is just cos of 132. So it's going to look like a nice big mess. So watch this. A squared, all right. The first one squared, like H tan 55. So H tan 55 squared plus B squared, which is H tan 50 squared minus 2 times H tan 55 times B H tan 50 times cos C, cos 132. Looks long, but don't mix up long with hard. This isn't hard. All you've done is just sub in whatever these were into the right places. A, B, cos C. Just let me know when you've done that. Are you guys comfortable? Anyone have any issues with that? Okay. Next line. This obviously just becomes, I mean, this is not plus or minus, they're all multiplied. So that just becomes h squared tan squared 55 plus h squared tan squared 50 minus 2. Now watch this. This is h times h, which is h squared. And then of course, everything else you've got left, which is that whole thing. Equals c squared. What does c squared equal to, by the way? I forgot to write that. C is 200 squared, right? That's 200 squared. Okay. All right, Josh. What letter are you trying to solve for?
H, isn't it?
Right? So now watch. You've got a h squared there and a h squared there and an h squared there. What are you going to do?
Could you cancel them out?
You can't cancel. You want to solve for h. So what did we do in the question above to just find h squared. Look, you had it like this and like this. You want only one
Factored it out.
factorized it, yeah.
Yeah.
Be careful with cancelling.
Yeah.
That's what you want to
My
get rid
bad.
of. Yep. So you're just going to factorize, and if you think of it like that, it just makes it makes it look easy again, but in reality, you've just done it in a very smart way. There it is, and then you plug all that into your calculator, and then just divide. Good work. So you guys, you would factorize h squared out. So this big mess, it's just h squared times all of this. You're going to plug all of that into your calculator, divide it through by 200 squared, and then square root it, and you're done. So h equals root answer, which is this guy divided by that. And let's hope we can all get the same answer. So I will go plug this into my calculator now. Tan 55 squared plus tan 50 minus 2 times tan 55. Tan 50 equals 132. If you plug this into your calculator, it should give you about 5.737, blah, blah, blah. Then we're going to go 200 squared divided by answer, square root it. Hopefully you guys get about 83.5.
Yeah.
Great work. I mean, and just by looking at all this, you'll know already what is the hardest bit of it. The hardest bit is meant to be, of course, this bit. It's meant to be really, really hard. But the truth is, the hardest bit is actually just working out your first diagram. You're able to get your diagram out eventually. You'll just get used to the algebra here. So,
Yep, I got it.
perfect. Just wait a few more minutes, make sure everyone write it all down. Maybe if you're looking over it, if you've got any questions.
Hey Sam,
Yes,
do you know how your whole tactic for starting is like doing practice exams and stuff?
correct.
Yeah. This time I got an assignment, right?
Yes.
Do you reckon I should start doing those practice exams now or like closer towards the prelims?
Well, your prelims are going to be in exactly 15 weeks from now. Just say
15 weeks.
15 weeks, pretty much, give or take. Now, I would say if you were to do one exam paper a week, that means you would have completed 15 papers for math. Then you've got to do that for everything else. So I think if you start one a week per subject, which means let's say give or take one exam a day per subject or exam questions per subject, yes, you might just be ready for your prelims. And that's safe, like one exam a day per subject.
One exam a day per subject from
Yeah.
now.
Yeah, so for one subject, sorry, for once, like you'll only do math every Monday, let's say. Then you'll do an English, maybe you memorize your English essays every Tuesday. You might do some physics questions, physics papers, revising mechanics, whatever, every Wednesday. Every Thursday you'll be doing your, let's say, history. Every Saturday you might be doing something else, and then every Sunday you do something. Then that's it. You just do that for the next 15 weeks.
And how long should you usually spend on doing like
Papers, exam papers, I would say about an hour right now.
hour right now?
Yeah. So you shouldn't do full blown out, 2 hour, 2.5 hour exam papers just yet. You'll burn yourself out. So right now you're doing about an hour, maybe 50 minutes, just going through exam questions, and that's literally, I don't know if you guys can see the tab. I have it ready for you guys. The trig exam. You know, I want you guys to go through and start actually answering trig questions and trig exams. Like, you need to do that. So, yeah, about 50 minutes. That's only worth about 50 minutes or so. This exam. It's only 2 pages.
Yep.
1, 2. The next one's extension. So, about an hour's right. And
What
all
if
of
we
these.
want to get very good? Like,
That again.
what if we want to get a really good mark?
That is a really good mark. You got to
Just
exam.
one exam each week?
Yeah.
Or like, okay.
Yeah. But I mean, let me see. Can you even do that? You're saying, okay, what if I want to get a really good mark? That is the actual secret. That's it. Just keep it consistent and do exam papers. It's more
Yeah.
the consistency than the amount. It's not really about the amount. It's about just staying consistent with it, which is what I was trying to say. Like every Monday, you just know, okay, cool. It's 7 o'clock. At 7 o'clock, I've finished off all my homework, whatever. From 7 to 8, I'm meant to be doing my exam paper for math. All right, it's Tuesday. Tuesday, usually from 8 to 9, I do my exam papers for physics. Okay, it's Wednesday. Wednesday from 6 to 7, you've got to timetable it in, and it's got to start. Exams. Every single one of these, you can see, are just from all the top schools. That's all I get these exams from. So you guys got to do that. All right. Yeah, let's try. Let's do one more. Why not? Last one. Bang. Paste. Maybe I'll give you guys a few minutes. I'll give it to 550. I'll give you 4 minutes to just try it on your own. Do everything you know you got to do. Maybe follow the same techniques I've said. And then I'll do it as well.
Hey, sir. In some of the questions, like in the questions you showed us so far,
Yes.
at the end they say on the same level ground. Like, can that
Yeah.
change? Or
Can it change for your? Well, it never changed for 3 units. So I'm just going to say no. It will not
Alright.
change for 3 units. No way. No way. In fact, I don't think. Yeah, we don't even do that until probably second year university.
Oh wow.
You know, because it becomes very complex after that. The reason why that's there is just to tell you that the Q is on the top and the R is at the bottom. So when you're drawing it, you know how to draw it, I guess. That's its main purpose. All right. I just want to try to see if I Google your question, Rad. I want to see if we can get some other responses. Let's see. How to get an eta of 99 plus. Now, I'm sure we should be able to get. All right, there we go. Here we go. From Matrix, eta notes, some tips. How does you get to hear from? And you're just gonna see what he'll say.
Oh, I've seen that website.
Sorry.
Seen that website.
You've seen it? There you go. My number one advice. When I get home from school each day, I'll make a list of tasks I will do that afternoon, which will allow me to achieve my weekly goals. Make a list of small tasks for each day to achieve your weekly goals. What should you start doing? Look at the first point she just said. There you go. Past papers. The first study tip that I found particularly effective is to do a lot of past papers. I chose to complete past papers from a variety of schools, focusing mainly on those from the top 5 ranked schools. Can I say it anymore? I mean, look, I just Googled a random thing and there you go. And I know there's no way, like, any of these people will not say, any of these 99 people will not say, hey, go ahead and it's fine. Like, you don't even need to do an exam paper. I completed over 1,000. You have to do past papers. There's just no way you're going to get anywhere without. When studying maths, here we go, that's a good one for you guys. When studying maths, I start by revising any concepts learned during class. Revise instead of restudy. I then go through multiple textbooks to ensure that I have a solid fundamentals understanding. Make sure they're a great resource that really helped me in covering my basics. That's it. The best way to test your understanding is to try to teach others, always questioning why. I always said that to you guys. Try to teach others, become robotic. Practice, practice, practice. The only way to improve. I was going to play as many practice questions and exercises as I could and impose strict time challenges on myself. I always say time yourself. If you think you can do it in a minute, try to divide it by 2. Divide it by 2 again. So pretty much, I've told you guys what to do. Yeah, and what do these people say? That's it. Motivation, don't worry about your scaling, study notes, overcoming procrastination. That's what you're doing right now. Eden, that's what you just said to me right now. Oh, okay. Like, but how do I get the best mark? Like, it seems like you're just looking for a one-way procrastinate. Just forget it. Don't worry, just do it. My biggest piece of advice, do not stress about your mark for HC trials if it wasn't what you expect. And this goes for any test, really. My half-yearly exam was a doozy. Coming up, the absolute worst. Look, I feel like you should study for your HSC trials really hard. In fact, we're going to study for our HSC trials harder than our HSC. That's the last time you're going to affect your rank. So I don't agree with this person. You should really stress about your trials. You shouldn't stress about your HSC. That's my take on that. Hey, how to study. Ready? First method, grab a past paper. Done. Set a timer. 15 minutes. Your job in that 15 minutes is to read through the paper. You read a question, you don't know how to answer it, mark it. So basically look at every question and think honestly to yourself. Could I answer that? If the answer is no, mark it. At the end, you just do every marked question. This makes study more efficient because you answer 10 questions you already know how to do. Also, you can shorten the time to get good practice. But you get it. First method, grab a past paper and start. Time it, get going. Stop procrastinating, pretty much. You guys are trying to avoid the unavoidable. All right. Rad, I think that answers your question, right?
Definitely.
Definitely. Just do it. Stop thinking, how do I do it and stuff. Just do it. Just sit down and just do it. Just print one and start. Don't worry. Even if it's the worst thing. Like my first one, I got 20%. Then 22%. Then 27. Then 37. Then 50. Then 20 again. Then I went up again, and you went down and up and down, and until you eventually stabilize at 80, 85, 90, 95, whatever it will be. All right, you guys. The angle of elevation of a tower, QR. R was on the ground. Q's on the top. Hey, of height 80 meters. Okay, fair enough. This time it tells you the height is 80 at a point y due east of is 45 degrees. That's y. From another point x, the bearing of the tower is 30 degrees. So again, that's x from another point. So from here this bit here would be 30 degrees. You'll have your elevation, but this bit here is 30 degrees, which means when you draw this bit as well, you know from alternate angles, this is also 30 degrees. The elevation is 28. The points X, Y, and R are on the same level ground. Damn it, they didn't tell us the distance between X and Y, huh? And that's annoying. You might find that. All right, we'll see. Show that XRY is 120. Well, I think we already know that. 30 plus 90 is 120. Everyone's okay with that one? Anyone not okay with A? Show that XR is equal to 80 on 10. Okay, so again, for B, you just start with 10, 10, 28. 99.99% of the times it's 10. So 10, 28 equals opposite over adjacent. And again, XR equals 80 on 10. Try to avoid what your teacher will write, which is this. I mean, it might work nicer because you're not using fractions, but you can't use this in your calculator, so it's useless. RY, tan 45, equals opposite over adjacent. Tan 45 is 1, so therefore RY is just 80. Hence, find the distance between X and Y. Actually asks us to find the distance this time. How do we find that distance? Anyone able to actually find the distance?
Yeah,
All right, what'd you get?
I got 202.
Let's have a look. And how'd you do that?
Cosine rule.
Yeah, cosine rule's right. So xy squared must equal to ry squared plus xr squared, which is 80 on tan 28. 80 squared on tan 28 squared. Minus, we're going to run out of room, minus 2 times A times B times cos C. It's pretty much what you wrote, Lissandra.
Yeah,
All right, let's hope you got it out. Plug it all into our calculator. So let's have a look. 80 squared plus 80 squared on tan 28 squared minus 2 times 80 times 80 on tan 28 times cos 120. Then you get an answer. That's great. You square root it, and I think you are on the money. 203 though.
yeah, because
0.66.
I validated my 80 on 10, 28. Okay.
Say that again. Oh,
The 80 on 10, 28. I made it like 150 from the beginning.
maybe that's an important rule for you to remember. Don't round during your working out. Always round at the end. So if you write 150, it's not a problem, but don't use 150. You have to use it exact. And if you ever want to store it in your calculator, don't forget you could press Shift RCL, which is just on top of the 7, and then pick a letter, like A or something, B, and then it's stored. And you can just use that instead of this number 80 on 10, 28. But definitely don't round and then use a rounded answer, and then you're going to re-round. That's why you probably went wrong. So if this was, I don't know, a 2 marker at the end or 3 marks, you would unfortunately not get the full mark because that's to the nearest meter. You had 202. The answer was meant to be 203.
Yeah, Sam, I did the same thing. How many marks would I lose at the end for the rounding?
Yeah, just the 1 mark, but come on, we don't want to lose 1 mark. Look at all this hard work you've just done. You've just learned, this is worth 5 marks. You don't want to get 4 out of 5 when you've just learned all this beautiful math to get 4 out of 5 because of the nearest meter.
Yeah, that'd be a disaster.
Yeah, exactly. So come on, don't round during. You guys got to just remember that. Write it. Like, it's okay to write it, when you're using it, whatever, but you can't actually use it for another question. So if there was ever a part B said, hey, get an answer out, and you wrote 150, fantastic, you got that right. Like, not a problem. It said write it to 1 decimal place or whatever, but you can't use that answer for part C. because then you're using a rounded answer for part C. You're meant to actually use the whole figure again, and that usually tricks students. I feel like they can use a rounded answer from part B that just said find this or show or in whole number or whatever. Never use it. That's it. Just never use a rounded answer. Plug all this into your calculator. That's it. That's all I can say to you guys. All right. I'm happy with that.